Hello friends, topic of today's video is balancing chemically in case of compounds. It is also very important to know why the equation should be balanced. Let us have a look at a reaction in which carbon combines with oxygen to form carbon monoxide. On reactant side, that is on the left side, we have one carbon atom and two oxygen atoms, and on the right side, that is product side, we have one carbon and one oxygen. So if we see one carbon on both sides, reactant side and product side, but oxygen is 2 on reactant side and product side has only one oxygen. That means one oxygen was destroyed during chemical reaction, which is not possible because according to law of conservation of mass, matter can neither be created nor destroyed. In some other reaction, product side may have more atoms of particular element than reactant side. That is also not possible because atoms cannot be created. So to comply with law of conservation of mass, we need to balance chemical equations. Just before starting to balance equations, let us see what a balanced equation is. A balanced equation is one in which number of atoms of each element on reactant side and on the product side is same. First equation which we are balancing is carbon reacts with oxygen to form carbon monoxide. One important thing to remember is formulas will remain as they are. Like carbon monoxide will be CO. We cannot make it CO2 to balance it. CO2 is carbon dioxide. Our product was carbon monoxide. So this is wrong method. So we have to write numbers as coefficient in front of compounds or elements to balance them. In this equation, carbon on reactant side and product side is 1. Oxygen on reactant side is 2 and product side is 1. So to make it 2, we will place 2 as a coefficient in front of carbon monoxide. But that makes carbon 2 in product side. To equalize that, we write 2 as a coefficient of carbon in reactant side. Now the equation is balanced. In next equation, we have nitrogen reacts with oxygen to form nitric oxide. We have 2 nitrogen atoms and 2 oxygen atoms on reactant side, but product side has only 1 nitrogen and 1 oxygen atom. So we can simply equalize it by writing 2 as a coefficient in front of nitric oxide and the equation is balanced. In next equation, zinc sulfide reacts with oxygen to form zinc oxide and sulfur dioxide. Let us balance this equation by writing number of each element on reactant and product side. Elements involved in this reaction are zinc, sulfur and oxygen. Zinc is 1 on both sides, sulfur is 1 on both sides, but oxygen is 2 on reactant side and 1 plus 2 on product side. Number of oxygen atoms is odd on the right side and even on the left side. To make it even, we multiply zinc oxide by 2, but that disturbs balance of zinc. To equalize that, we multiply zinc sulfide by 2, but then sulfur becomes 2. So we multiply sulfur dioxide in the products by 2. Now the remaining element is oxygen. Product side has 6 oxygen atoms, 2 in zinc oxide and 2 to the 4 in sulfur dioxide. So to equalize that, we will multiply oxygen by 3. That becomes 3 to the 6. So we have 6 oxygen atoms on both sides. Number of elements now are equal on both sides and the equation is balanced. Next equation, aluminium reacts with oxygen to form aluminium oxide. Product has 3 oxygen, which is odd number. We will try to make it even by multiplying aluminium oxide by 2. So that makes 2 3s are 6 oxygen atoms on right side. On left side, we will make it 3 2s are 6 oxygen atoms. So oxygen atoms are equal. Aluminium is 2 2s are 4 on right side. To equalize it, we will write 4 as a coefficient of aluminium on reactant side. So we have 4 aluminium atoms on reactant side and 4 on product side. 6 oxygen atoms on reactant side and 6 on the product side. So the equation is balanced. Next equation is magnesium reacts with nitrogen to form magnesium nitride. We have nitrogen atoms 2 on each side, but magnesium is 3 atoms on the product side but 1 on reactant side. So we can easily equalize that by writing 3 as a coefficient of magnesium in reactants part. And the equation is now balanced. Next equation is aluminium reacts with nitrogen to form aluminium nitride. Here we have 2 nitrogen atoms in the reactant side and 1 on product side. To equalize that, we will write 2 as a coefficient of aluminium nitride. When we do that, aluminium balance becomes disturbed and we have 2 on right side and 1 on left. We can easily balance that by writing 2 as a coefficient of aluminium in reactants. So we have 2 aluminium atoms on each side and 2 nitrogen atoms on each side, and the equation is balanced. Next equation, nitric oxide reacts with oxygen to form nitrogen dioxide. Nitrogen atom on both sides are 1, but oxygen atoms we have even number on right side and odd number in NO. So we will try to make it even by writing 2 as a coefficient of nitric oxide. If we do that, then nitrogen balance gets disturbed. To equalize nitrogen, we will write 2 as a coefficient of nitrogen dioxide. So we have 2 nitrogen atoms on both sides. Let us check oxygens. 2 oxygen plus 2 oxygen, 4 on left side, 2 to the 4 on right side. So the equation is now balanced. Next equation, sulfur dioxide reacts with oxygen to form sulfur trioxide. We have odd number of oxygen on right side, so we will try to make it even by multiplying it by 2 or writing 2 as a coefficient of sulfur trioxide. If we do that, sulfur balance becomes disturbed and we have 2 on the right side and 1 on the left. So we will write 2 as a coefficient of sulfur dioxide. Then we will check oxygen atoms. Oxygen is 2 to the 4 plus 2, that is 6 on left side and 2 3s are 6 on right side. So equation is now balanced. Our next equation is hydrogen reacts with chlorine to form hydrogen chloride. We have 2 hydrogen atoms on reactant side, 1 hydrogen on product side. Even chlorine is 2 atoms on reactant side and 1 on product side. This can easily be equalized by writing 2 as a coefficient of hydrogen chloride. So we will have 2 hydrogen atoms on each side and 2 chlorine atoms also on each side, and the equation is balanced. Next equation is iron reacts with chlorine to form ferric chloride. Iron is same on both sides, but chlorine we have 2 atoms on left side and 3 atoms on right side. So we will do 3 2s and 2 3s. Left side we will write 3 as a coefficient of chlorine, and on right side we will write 2 as a coefficient of ferric chloride. Number of chloride atoms now is equal on both sides, but now this has disturbed balance of iron on both sides. We have 2 on right side and 1 on left side. This can easily be fixed by writing 2 as a coefficient of iron in reactant side. So the equation is now balanced. Next equation is hydrogen sulfide reacts with chlorine to give sulfur and hydrogen chloride. We have 2 hydrogen and 2 chlorine atoms on left side and 1 hydrogen and 1 chlorine on right side. Sulfur is 1 on each side. So to equalize hydrogen and chlorine, we can write 2 as a coefficient of hydrogen chloride in product side. That will equalize all the atoms and equation will be balanced. In next equation, potassium bicarbonate decomposes to form potassium carbonate, water and carbon dioxide. There are 2 potassium atoms on right side and 1 potassium atom on left side. So we will try to equalize that by writing 2 as a coefficient of potassium bicarbonate. So we have 2 potassium on either side. Now look at CO3. 1 CO3 is taken up by potassium carbonate and 1 CO3 is given out as carbon dioxide plus 1 oxygen is given to water. So 2 CO3 are balanced. Now let us look at hydrogen atoms. We have 2 hydrogen atoms on either side of the equation. So our equation is now balanced. In next equation, potassium reacts with carbon dioxide to form potassium oxide and carbon. This equation has 2 potassium atoms on right side and 1 on left side. So number of potassium atoms is unequal. Also number of oxygen atoms is not balanced. It is 2 on left side and 1 on right side. So first we will try to balance oxygen atoms by writing 2 in as a coefficient of potassium oxide. When we do that, potassium becomes 4 atoms, 2 to the 4 atoms. So we will correct potassium atoms on left side by writing 4 as a coefficient of potassium. So now we have 4 potassium atoms on both sides, 2 oxygen atoms and 1 carbon atom on each side. So the equation is now balanced. In next equation, calcium hydroxide reacts with nitric acid to form calcium nitrate and water. Number of NO3 radicals is 1 on left side and 2 on right side. We will try to balance it by writing 2 in as a coefficient of nitric acid. Now we have 2 NO3 radicals on either side and 1 calcium atom on either side. Let us now see how many oxygen and hydrogen atoms we have on either side. From calcium hydroxide we have 2 oxygen and 2 hydrogen. From nitric acid we have 2 hydrogen. So in all 4 hydrogen and 2 oxygen. But on right side we have 1 water molecule. So if we write 2 as a coefficient, we will have 4 hydrogen and 2 oxygen. So that will balance the equation. Next equation, potassium reacts with water to form potassium hydroxide and hydrogen gas. Number of hydrogen atoms is 2 on left side and 3 on right side. To make it even on right side, we write 2 as a coefficient of potassium hydroxide. But then potassium becomes 2 on right side and 1 on left side. So we will write 2 as a coefficient of potassium on left side also. Let us now check hydrogen and oxygen atoms. On right side we have 2 oxygen atoms and 4 hydrogen atoms, 2 from hydrogen and 2 from KOH. To equalize that, we will write 2 as a coefficient of water, so we will have 4 hydrogen and 2 oxygen on left side also, and the equation will be balanced. Next equation, calcium reacts with water to form calcium hydroxide and hydrogen gas. We have 1 calcium on either side. Let us have a look at hydrogen and oxygen atoms. On right side we have 2 oxygen atoms and 4 hydrogen atoms, 2 from calcium hydroxide and 2 from hydrogen. So if we write 2 as a coefficient of water on left side, we will have 4 hydrogen and 2 oxygen. That will balance the equation on both sides. Next equation is aluminium reacts with water to form aluminium oxide and hydrogen gas. We have 1 aluminium atom on left side and 2 on right side. So we will write 2 as a coefficient of aluminium on left side. We have 3 oxygen atoms on right side and 1 on left side. To balance that, we will write 3 as a coefficient of water on left side. Let us check hydrogen atoms. We have 3 to the 6 hydrogen atoms on left side. So we will write 3 as a coefficient of hydrogen on right side also. That will balance the equation. Next equation is iron reacts with water to form ferric oxide and hydrogen gas. We have 3 iron atoms on right side and 1 on left side. That we will balance by writing 3 as a coefficient of iron on left side. We have 4 oxygen on right side and 1 on left side. That we will balance by writing 4 as a coefficient of water on left side. Now we will check hydrogen atoms. 4 to the 8. We have 8 hydrogen atoms on left side. So we will write 4 as a coefficient of hydrogen on right side also. That will balance all the atoms on left and right side of the equation. Next equation, zinc reacts with sodium hydroxide to form sodium zincate and hydrogen gas. We have two sodium atoms on product side or right side and one sodium atom on reactant side or left side. We will equalize that by writing 2 as a coefficient of sodium hydroxide. So now we have two sodium on each side, one zinc on each side. We will see how many hydrogen and oxygen are there. We have two oxygen and two hydrogen on product side. We have two hydrogen and two oxygen on reactant side. So equation is balanced since all the atoms are equal on both sides of the equation. Next equation, zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. On product side we have two chlorine atoms and one chlorine atom on reactant side. We will try to equalize that by writing 2 as a coefficient of hydrochloric acid. We have one zinc atom on either side. Now let us see hydrogen atoms. 2 on right side and 2 on left side. So our equation is balanced. Next equation which we are doing is aluminium reacts with sulfuric acid to give aluminium sulfate and hydrogen gas is liberated. On product side, that is on right side, we have two aluminium atoms and on reactant side we have one aluminium atom. To equalize that, we write 2 as a coefficient for aluminium. Next we will compare sulfate radicals on both sides. We have 3 sulfate radicals on right side and 1 on left side. To equalize that, we will write 3 as a coefficient for sulfuric acid. Now what is left is hydrogen. Hydrogen we have 3 to the 6 hydrogen atoms on left side and on right side we have 2 atoms. To make it 6 we will write 3 as a coefficient. Now all the atoms are balanced on both sides and equation is balanced. Next equation is hydrogen reacts with oxygen to form water. We have odd number of oxygen atoms on right side and even number on left side. We will try to make it even by writing 2 as a coefficient of water, but that disturbs balance of hydrogen. We have 4 hydrogen on right side and 2 on left side. To equalize that, we write 2 as a coefficient for hydrogen. That balances the equation. Next equation is nitrogen reacts with hydrogen to form ammonium. Here we have one nitrogen atom on right side, that is product side, and 2 nitrogen atoms on reactant side. So to equalize that, we will write 2 as a coefficient for ammonia. We will now check hydrogen atoms on both sides. Hydrogen atoms are 2 on reactant side and 6 on product side. To equalize that, we will write 3 as a coefficient for hydrogen. Now we have 2 nitrogen atoms on both sides and 6 hydrogen atoms on reactant and product side. So equation is now balanced. In our next reaction, ferric oxide reacts with hydrogen to form iron and water. We will first compare Fe atoms. We have one Fe atom on right side and 2 on left side. We will equalize it by writing 2 as a coefficient of iron. Now we will equalize oxygen atoms. We have one oxygen atom on right side and 3 on reactant side or left side. We will equalize them by writing 3 as a coefficient for water. Now what remains is hydrogen. Hydrogen we have on right side 3 to the 6 hydrogen atoms. On left side we have only 2. So we will write 3 as a coefficient for hydrogen. That will equalize all the atoms on both sides and equation will be balanced. In next equation, potassium bromide reacts with chlorine to form potassium chloride and bromine. We have one bromide atom on reactant side and 2 bromide atoms on product side. We will equalize that by writing 2 as a coefficient for potassium bromide. Chloride atoms we have 1 on right side and 2 on left side. We will equalize that by writing 2 as a coefficient of potassium chloride. All atoms on reactant and product side are equal and the equation is balanced now. Next equation is sodium hydroxide reacts with chlorine to form sodium chloride and sodium hypochlorite and water. Right side has two sodium atoms, one in sodium chloride and one in sodium hypochlorite, but left side has only one sodium atom. So we will equalize that by writing 2 as a coefficient for sodium hydroxide. Of the remaining elements, we have two chlorine atoms on each side, two hydrogen atoms and two oxygen atoms on both sides. So the equation is now balanced. Next equation, sodium bicarbonate reacts with sulfuric acid to form sodium sulfate, water and carbon dioxide. Product side has two sodium atoms and reactant side has one sodium atom. So we will equalize that by writing 2 as a coefficient for sodium bicarbonate. We have one sulfate radical on product and reactant side. We have 2 HCO3 from sodium bicarbonate and 2 hydrogen from sulfuric acid. In all, 4 hydrogen atoms and 2 CO3. So that they will form 2 carbon dioxide molecules and 2 water molecules on product side. And the equation is balanced. In next equation, we have magnesium reacting with carbon dioxide to form magnesium oxide and carbon. We have magnesium one atom on each side. Carbon also we have one atom on each side of the equation. But oxygen atoms are two in the reactant side and one on the product side. So we will try to equalize by writing 2 as a coefficient for magnesium oxide. When we do that, magnesium balance becomes disturbed, and to equalize that, we will write 2 as a coefficient of magnesium in reactant side also. The equation is now balanced. In next equation, ferric oxide reacts with carbon monoxide to form iron and carbon dioxide. You will observe carbon monoxide is getting oxidized to carbon dioxide. One carbon monoxide needs one oxygen atom to get oxidized to carbon dioxide. But we have 3 extra oxygen atoms. So we will make 3 carbon monoxide changing to 3 carbon dioxide. Element remaining is iron, which is 1 on right side and 2 on left side. We can balance that by writing 2 as a coefficient of iron. And the equation is now balanced. In next equation, calcium oxide reacts with hydrochloric acid to form calcium chloride and water. We can see calcium is one atom on both sides, oxygen is one atom on both sides, but hydrogen we have 2 on right side and 1 on left side. Even chlorine is 2 on right side and 1 on left side. To balance that, we will write just 2 as a coefficient of HCl and the equation is balanced. One last equation we will balance, and it is quite simple one. We have carbon dioxide reacting with carbon to form carbon monoxide. We have 2 carbon atoms on left side and 1 carbon atom on right side. Oxygen also 2 on left side and 1 on right side. To balance that, we will just write 2 as a coefficient of carbon monoxide and the equation is balanced. We have balanced 32 equations in less than 25 minutes. So you'll see it is not very difficult. Just keep practicing and also keep subscribing and sharing with your friends. Thank you for watching.